Okay, I'm going to go through part 3 of this paper, and we did the first 3 questions already. This is from November 23, and this is paper 2. So have a look at the first 2 parts already. So we've done the first 3 questions in the first 2 parts, and the next question is question 4, and it's to do with a step-up transformer. Okay? So a step-up transformer has a number of parts which basically are the primary coil, yeah? So if you think of the primary coil as the coil on your left, and then there's a secondary coil on the right. And you'll notice that the 2 coils are actually not connected because each coil is made of insulated wire. So these coils are made of insulated wire. So electrically, these are not in contact. However, they are connected through this iron core by a magnetic field. And in the primary circuit, you've got AC current, symbolized by this squiggly line between the 2 circles. That's a AC input. And then you've got an output, which will also be an AC output. So basically you've got the first coil producing a magnetic field, and because the current in the first coil is alternating AC, then you're going to get an alternating magnetic field which keeps on changing positive, negative. When the current goes from positive to negative, the magnetic field will change direction. And the second coil detects that change in the magnetic field, because remember that electromagnetic induction, which is what a transformer uses. A transformer is basically an application of electromagnetic induction. So they tell you that the input power of the transformer is 16 watts, and they're giving you the value to 2 significant figures. You'll see that the 16 watts is your input power, and if you remember, power is energy times power times time is equal to energy, because they want you to work out the energy. Okay, now it says the transformer is used for 2.5 hours. Now remember that the SI unit for time should be in seconds, so you need to change the time into seconds. Again, you'll notice that they're giving you 2 significant figures. So data, they're telling you, we only know the data to 2 significant figures. So they want you to calculate the energy transferred, knowing the power, which is a rate of use of energy, to the transformer. So you've got 16 watts of AC electricity going in, so we know the power in watts, and we know the time in hours. You've got to change the time in hours into seconds, so that's multiplying by 60 to get into minutes, and you also need to multiply by 60 to get it back into seconds. So that's how you get it into seconds, multiplied by the power which was given to us as 16 watts, and you'll get to 3 significant figures, a value of 144,000. Now that's to 3 significant figures. Okay, now we've looked at the data, and the data provided is to 2 significant figures, so really your answer should be rounded up to 2 significant figures, which is what I have done in the final answer. So the final answer, I round it up to 2 significant figures, 140,000, because that's as accurately as we can get the answers. Now the mark scheme, has shown you the same, so you can look at the mark scheme. Now transformers are from topic 6, which is on magnetism and electromagnetism, And in fact, transformers are using electromagnetic induction when you induce a current, or a voltage from one place to another. So basically, you got electricity in the first coil, alternating current, producing alternating magnetic field inside the iron core. So the iron core is a way of transferring the electrical energy from coil 1 to coil 2. And the coil 2 then gives you an output voltage. Okay? And the voltage output will go down in this case because the secondary coil, has fewer turns, the number of turns in the secondary coil here is less than it was in the primary coil here. Okay, so if the number of coils goes down, then the voltage will go down in that ratio. And we're going to need that to understand how transformers work. So what does the next part of the question ask you? The next part of the question says, explain how a transformer works. Now, remember, so a transformer can either make the voltage go up, and that's called a step-up transformer, or it can make it go down, in which case it will be called a step-down transformer. And then they tell you, to get your explanation all the marks, in your answer include reasoning for using two coils. Why do we have two coils? Yes, so we just talked about primary and secondary coils. One produces the magnetic field and the other detects the magnetic field, and it induces a voltage as a result in the secondary coil. Why do we have the iron core? Well, the iron core is a soft magnetic material, and it can strengthen the magnetic field strength, by up to 50,000 times. So if you didn't have the core, there would still be some kind of magnetic linkage between the primary and secondary coil, but it wouldn't be a very effective transformer. And why do we need to use an AC power supply? And the answer is because the electromagnetic induction, if you want to induce a voltage, you need to have a changing magnetic field. Yes, you either can produce that changing magnetic field by movement, or you can change it by having an AC current. So an AC current is a changing current, and a changing current will produce a changing magnetic field. So this is the underlying theory. Now you've got to break it down to get 6 marks for yourself. Okay? All right. So let's have a look at the mark scheme. What are they actually giving you marks for? So we're looking at part B. So they're saying they will give you the 6 marks from any of these points. So it can either step up, a transform can either step up or step down the voltage. I mentioned that. And it tells you that this is the main thing. The current in the primary coil is the one that's got the AC current in it. It produces the magnetic field. So that's the starting point, producing a magnetic field. Now, because the current is a changing or alternating current, it will also cause a changing or alternating magnetic field. Okay? So because we got that, and then you remember you need to say that the core, the iron core, strengthens the magnetic field, and it also therefore strengthens the connection between the primary and the secondary coil. So the idea is that iron works really well in electromagnetic situations, and a transformer is an electromagnetic application of this theory. And because it's a soft magnetic material, it can gain and lose its magnetism easily. So as soon as the current changes direction, the magnetism will lose its direction and then turn to the opposite direction when the polarity of the alternating current changes. Now, this changing magnetic field, interacts with the secondary coil, which is a conductor, and the secondary coil then induces a voltage inside it. Yeah? So you have an induced voltage in the secondary coil. Now, the transformers don't work with steady currents. Yeah? So it's the fact that the current is going up and down, alternating, that produces an alternating magnetic field, which then induces the EMF in the secondary coil. Okay? So I hope that makes sense. Now, you should have written your answers out and then checked how many of these 9 points, they're giving you 9 ways to get these 6 marks. Okay? Hope that makes sense. So I explained it in note form, and you've got to write it out in bullet points, and they're giving you your marks for clarity, detail, and depth. Okay? So there's 9 marking points. And then finally, for this question, part C says, state how the primary coil of the transformer can be changed to increase the output voltage. So if you want the output voltage, yeah, you want to increase the output, yeah, voltage, that's in the secondary coil. If you want that to change, what can you do about the primary coil? How can you change the primary coil? Well, the only way you can do that is by decreasing the number of turns in the primary coil. So you need to really say, decrease the number of turns in the primary coil. So that's what they want you to change. Okay? There is no other way of doing it. Okay? Because obviously the voltage is set, and therefore if you want to get an increased output voltage, you want to have more turns as a ratio in the output secondary circuit, the secondary coil, compared to the primary coil. So you want the number of turns to be low in the primary, and you want the number of turns in the secondary coil to be high. And that's how a transformer works. So you could say the output voltage, V2 over V1, if you remember the equation, is equal to N2 over N1. And it's only a 1-mark question, but really it applies to this theory. Okay? So if you reduce N1, yes, then N2 over N1 becomes larger, so V2 will go up compared to what it was before. Okay? Hope that makes sense. And that's the end of part 3, which is on transformer theory. Yeah? And then the next question, we'll come back to it, is on changing state. Okay, well, if you found that useful, don't forget to like and share the video with your friends, and do use the explanations to improve your own answers. So once you've done your answers, look at how you can get your wording more clearly put down. Make sure you know the key terminology that you've got to use, the technical vocabulary, and make sure you've got enough depth and detail in there, and that will allow you to get the full marks. So thank you for watching the video, and hopefully see you in the next video, and I'll try and do it soon. Okay, bye for now.